Hello everyone, this is Dr. Shirisha, working as Associate Professor in Institute of Aeronautical Engineering. Today we are going to look at a unique program which says that how to merge two sorted linked list into a third linked list, right? So I'm going to sort two linked lists. The inputs are two sorted ones and I'm going to merge them into a third one, right? So let's start basically with what a linked list data structure is. Linked list is a structure where data is related to another data which is present at some other location but not consecutive memory location. That is, it is a linear structure. That is, one data element is related to another data element, one-to-one cardinality, but the data is not present in contiguous memory locations. And these linked lists are categorized in three different categories. One is single linked list, double linked list, and circle linked list. Their structures are like this. Single linked list. Every node is having two parts. One part is the data part and the other is the address part. Data part is, as the word says, it holds the data of that node, and the next part holds the address of the next node. You can see that you can travel only in forward direction. We cannot revert back. If you are at node 15, say, you can only move to node number 20 because this node address part holds only the address of the next node, which is 20. Right? You cannot go in the reverse order. Okay. To overcome that, circular linked list have come into the picture where the last node is going to hold the address of the first node. Thereby, if you are at node 20 and if you want to reach 10, then as you cannot go back in case of linked list, from the last node, you can reach the first node and then travel, right? So this is circular linked list. Even though you work with single linked list or circular linked list, the problem is your direction will be unilateral. You will be unidirectional. Only you will be moving in forward direction. To overcome that drawback, double linked list have come into the picture. In case of double linked list, a node have three parts. The middle part is the data part as usual. Its left part will hold the address of its left node and right part will hold the address of the right node. So wherever you are at, whatever the node you are present in, if you want to move in right direction, yes, you have the address of the right node. If you want to traverse in the left direction, yes, you have the address of the left node. That means you have the addresses of both the neighbors. Yes, I understand that the basic disadvantage of linked list is storing the addresses itself. Storing the addresses. So forget about the size of data you're using, but for the pointers, that is to hold the addresses, huge amount of data is required. It gets worsened when you go for double linked list. But they are very helpful when you work with the non-linear data structures. When you implement non-linear data structures with the linked list, it will be very easy. For example, when you try to implement a graph, generally when we work with graphs and if we use a two-dimensional array to fill the content, that is the relations between the nodes, most of the cells will be empty. That is, it becomes a sparse matrix where 50% or more than 50% of the cells are filled with null or zero or none, right? So saying that they're not related. So to overcome that, double linked list help you a lot. Or even you can use single linked list. Double linked lists are mostly useful to implement the non-linear structure trees, binary trees especially. To implement binary trees, the best option will be double linked list, where every node can hold its left and right child's address, right? So yes, the linked lists suffer with the complexity, the complexity which gets raised with the memory utilization, but it reduces the complexity when you turn the face towards time complexity. It reduces time a lot, right? So the node structure, the basic node structure of a single linked list. It is having two parts, as I said, data, and generally the address part is known as a link part, as it is going to link between two nodes by holding the address of a node, right? So this is the basic unit of a linked list, which is called as a node, right? So how to create a node? Very simple. As Python is an object-oriented programming, taking advantage of the same using classes. I have given a small explanation on how to create a node. So the class also have named it as node, and with the help of its constructor, I have taken two member variables. One is data and then other is next. So whatever data you are going to pass when you create an object of node class, that will be assigned or filled in the data part, whereas the next part is filled with none. Why none? Interesting question. Why? Because when you create a node, it is not linked to any other node in the first hand, right? So its address part is filled with none. As soon as you create a node or you link it with the start pointer, that none part will be overwritten. Okay. Coming to the second class, to implement a single linked list, right? So its constructor is filled with only one pointer, that is start. It is a pointer variable and it holds the address of the first node. Initially, when we start working with the linked list, as it is as there is no node and nothing to start with, it is filled with none. Once you create a node, establish a relation, or store the address of the first node in the start starts with the address of the first node, right? So have to create. If it is none initially, whatever the new node you are going to take, fill the address of that inside the start, and the construction of single linked list started. A case 2, where there are handful of elements and you are trying to insert an element at the tail, that is at the end, right? So you can see that 21 and 22 are the two elements, and the next element you want to insert as the last element. So have to do that just by naming the first element as temporary. Take the hops until unless you reach a node whose next part is none. Once you reach that node, which is the last node of the linked list, store the address of the new node in the temporary next. Have a look at this one. Initially, it is none. Now it is filled with 4000, which is nothing but the address of the new node. Thereby, you have inserted an element into the list, right? So this is how we can create. Now let's look at our task, which is to merge two sorted lists. Have a look at the first list, LL1, linked list. That's why I have taken the short form as LL. That's it. Okay, nothing much to think about that. Okay, so the first list is 21, 23, and 25. The second list is 20, 22, and 24. Now I have to merge them into a third list, LL3, which is located at location something 1000. It's first node. So first node will be 20. Second is the node fetch from the first list, which is having the data 21. From here I brought it, right? Next one will be 22. Next is 23, 24, and 25. So this is how I want my merged, sorted linked list to look like. So have a look at the inputs. I'll arrange the blunder which I have done over here. Yes, my first sorted list is 21, 23, and 25. Second sorted list is 20, 22, and 24. I want them to get merged into a third sorted list, which is like this, from 20 to 25, right? So please look into this one. This is what we are going to implement using Python, right? We are going to merge to sorted linked list. Now let's move to Python environment to look for the same. Yes, resume to Python, guys. This is the environment where I'm going to perform my task, that is to merge two sorted linked list. Let me open a file for the same, right? And this is the script which I'm going to use, and let me write the task which I'm going to do. Merge two sorted linked list to another linked list. This is the task which I'm supposed to do, because anyone who opens this file must be able to understand what this file is meant for, right? So always I start with the driver code, my dears. Why? Because I just want to be sure with what input my program is going to start, what are the functions which are required, basic functions which are required. I just write a skeleton of that with the driver code. Let me do that. Okay, so as a linked list Python is an object oriented programming. I'm going to use classes for the same to create nodes. Okay, so the first linked list, I have to create two linked lists, that two sorted ones. Yes, right? So let's do that. And the linked list is the name of my class, and the object name is ll1, and n is the number of elements that are to be present in my first list that I'm going to read. Input, right? Int of input, enter elements into ll1, right? That is the first one, the first list. I'm going to enter the elements into the first list. So I have to enter. So for I in range of n, that is n elements I have to. So ll1 dot append. This is the function which I'm going to write. Append function I'm going to write. Okay. So inserting at the last. Int of, and to that function I love to pass the elements, right? To get inserted. /n, enter the element, right? So once I fill this first list, now it is my job to read second list. So I'm going to create I'm going to create one more instance of the class linked list. And this again I have used the class linked list to create another object. Let the size of the second list be m. They didn't mention that equal length of sorted list. So I'm taking two different sizes of lists. So int of input. So enter the elements into the list, right? So or let me go with the first statement as it is. Enter the elements into ll2, right? So I'm going to enter. Then for m number of times, I'm going to repeat this loop, and I'm going to use the append function. This time I'm going to call the append function. At the append function, we're using the object L2. As append is already been defined, I want to change the name of my user defined function with a capital A, because with the lists, I hope you remember that we do have a function append which says that insert the element by default as the last element of the list, right? Which I don't want to do. Append int of input enter an element, right? Yes. Hope I am clear, right? Enter an element which will be inserted into the second list, right? Once I have created two lists, now the next job is to merge these two lists and place them in the third list. For that, I need to create an object of the class linked list, right? Once I create it, my task is to merge. I'm going to pass start, right? The starts of these two lists as parameters to the merge function, and which will be assigned to the start, link to the start. And I'm going to pass the same as my display function, right? LL3. The third list, the merge list, will be displayed, right? So I hope there ends my driver code. I have created two objects and the number of elements that will be present in those lists. One is of size, the first one is of size m, the second one is of size m. And then I've created a third object to which I'm going to pass the starts of the first two lists as a parameters to the merge function, and then that will be assigned to the start address of my third linked list, and I'm going to print the same. Okay, let's start the process. Right now, there are abundant functions which I need to fill, guys. Right, let me start with the class node to create a node, right? So the constructor of that will have, so self.data is equal to data part, and the next will hold none, right? So these are the two functions. This is the basic constructor to create a node. Next goes def. The second class, is the linked list class, which I have used many times. I have created three objects of the same. Okay, linked list, and the constructor of that will have the start pointer, which holds the address of the first node initially. Self start is equal to none, right? Then comes the append function, which I have used. Append function to which I'm going to pass the data, right? Right, fine. Data. New node is equal to node of data, right? If self start is having some content, then current is equal to self start, that is the temporary, the basic variable. Let's start with the first one, then while current next, that is you are going to travel till the end while the current next, right? While the current next, hop, take the hops. Current is equal to current next, right? Once you reach the last node, current next is equal to new nodes. That becomes, there you have, that means append function is used to insert the element at the last by default, right? So I have checked if my self start is not equal to none or not. If it is not equal to none, that is a list is already existing. So I have to append this new node as the last node. If it is not existing, then that means what if the list is empty? Else the first node will be the new node itself. So self start will hold the address of the new node, right? So this is how I'm going to append, right? Then have to print, right? Have to print. Very good question. I'm going to start with the current node. I'm taking the first node as the current node. While current, I'm going to print current data. Current data. Okay, current data with the end is equal to, so that the elements will be linked with an arrow mark, right? So current next, I need to take a hop to move to the next node, right? So this is how it is a simple function to print the elements in my list, right? So here in the class I have written the constructor to initialize the start, saying that the pointer start is going to hold the address of the first node initially, which is none. But when I started inserting the elements or appending the elements into my list, I have made a few changes, and I have seen that the first node address is held by the start pointer. Then I have written a print function also to print the content in the list after merging or before merging. Either way I can use it. Okay, right. Then after, let me move out of the class. Outside class. Here I'm going to write my merge function, right? To which I'm going to pass list 1 and list 2 as parameter. These are the two lists which I need to merge, right? So I'm going to take a start pointer 3 and a temporary variable, and these two will be the nodes of my class. Two nodes I have created. Okay, so while list 1 or list 2, either one of them exists, until unless either one of them exists. If list 1 and not of list 2, that is until unless the lists become or they reach last. If the first one data is less than or equal to list 2's data, then what you are going to do? Okay, list 1 data is less than or equal to list 2's data. List 1, I have not specified one, I think, my dears. Yes. If this is the case, then make the temporary next filled with the node with the list 1 data, or else list 2's data I'm going to fill with, right? So list 1 is equal to list 1 dot next. As I have used the content of list 1 as it is being incorporated into my third list, my pointer which is pointing to the first element will move to the second element, right? Else, that means if the content in list 1 is greater than list 2, then else what I have to do? I have to insert a new node with the data filled or fetched from list 2, as it is having a lower value. Now list 2, as the data in the list 2 is being used, I have to make its pointer hop. Okay, list 2 is equal to list 2 dot next, right? Then once it is done, temporary is at either way. Either temporary is pointing to the start 3, which is the pointer of my third list, right? So either you fetch an element from the first list or the second list. With either one of the insertions, the pointer of my third list, that is the final list, must be incremented. So out of this if else, whatever the case may be, either if can be executed or else can be executed. In both the cases, after these cases, my temporary will be incremented. Okay, this is how I'm going to merge them. By the end, once this while loop breaks, if either one of them breaks, I'm going to return start 3 dot next, right? So this is my function to merge two lists, sorted lists, right? So let me execute this one. I have named it also. So enter the first list, enter elements into first list, guys. Say one, only one element, enter the elements, say 4. So 2, 3, 4, 5. And yes, guys, with this we have completed the program to merge two sorted lists, right? So let's execute it now. Okay, so it will be asking for the number of elements in the first list, say 3 elements, say 21, 23 and 25, and the number of elements in the second list, say 2 elements. I'll give the intermediate elements 20 and 22. So the final list is yes, guys, this is the quick merge of two sorted lists. Let me run this one. Once you run this one, it is asking for the number of elements into the first list, say 3, 1, 3 and 5. 3 elements. So let the elements be 21, 23 and 24. And let the second list may have 4 elements, say 20, 22, 25 and 26. And this is how we are going to merge them, right? I hope you understood how to merge two sorted lists into a third list, framing them into a third list. So please do follow my videos, guys, and see that you work with the single linker list much more frequently, as it is a very important topic in terms of placements and your academics also. Do follow my next video where I'm going to show you how to reverse a single linker list. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.